Hello everyone, can you hear me? Can someone please confirm if everything is fine, if voice is fine, so that we can start? Awesome. How was the contest today? How was the beginner contest today? Yeah, I'm sorry that we started very late. I'm really sorry for that. Yeah. What about the rest of you? Three. Awesome. Four. Has anyone solved more? There were 7 problems. So, yeah. Okay, I think we can start discussing the problems. Let me make myself smaller. Okay. Yep. I personally haven't participated in the contest and I haven't read the problems yet, but I wanted to come here and so that we solve it together. And I thought maybe it would be a good opportunity this way. Oh, that's bad. And hi, Vasif. I think, yeah, I didn't see you yesterday, and I think there wasn't a contest, and I didn't see many of you for a long time. I couldn't see many of you for a long time because there was no contest. Yeah. Yeah, I see. I see. That's bad. So, okay, let's discuss the problems. First, the first problem, this is so good. You see that there are only 2 lines as a statement. That's really great. So, it says that there are n buildings lined in a row. The building number I from the left has a height of h sub I. Determine if there is a building taller than the first one from the left. If such a building exists, find the position of the leftmost such building from the left. Okay, this seems like a very easy problem, right? You just need to find the first element greater than a of 0. Right? So you have just a for the first I such that a of I is greater than a of 0 is gonna be your answer. Is it fine? Shall we move on to the next one, or do we need to discuss this problem more? Yeah, so the first one seems very easy. Yeah. Okay. Let's go on to the next one. The Adler amusement park has an attraction that can accommodate K people. Now there are N groups lined up in the queue for this attraction. The ith group from the front consists of a sub I people. For all I from 1 to n, it holds that a sub I less than or equal to k. Takahashi, as a staff member of this attraction, will guide the groups in the queue according to the following procedure. Initially, no one has been guided to the attraction and there are k empty seats. If there are no groups in the queue, start the attraction and end the guidance. Compare the number of empty seats in the attraction with the number of people in the group at the front of the queue and do one of the following. If the number of empty seats is less than the number of people in the group at the front, start the attraction. Then the number of empty seats becomes k again. Otherwise, guide the entire group at the front of the queue to the attraction. The front group is removed from the queue and the number of empty seats decreases by the number of people in the group. We can go back to step 1. Here, no additional groups will line up after the guidance has started. Under these conditions, it can be shown that this procedure will end in a finite number of steps. Determine how many times the attraction will be started throughout the guidance. So we have k seats, and each time we have some groups. The group number I has a of I people, and we need to find some partition such that each group, some maximal partition such that each part has at most k people, right? We have n groups. Each one of them, each part should have at most k people. So we can do greedy. Right, we can just start, and as long as we can take another group into our part, we can just consider that group as well, and we can continue as long as the sum is at most k. And if we see that adding a new group to it will have the sum to be greater than k, then we will not add that one, right? So we can just use greedy. For example, in this problem, we have 2 and 5 cannot be added to it because k is 6. So it's only this 2. Then we have this 5 and we can add this 1 as well. Then we have this 4 and we can add this 1 again, and then we have this 2 and this 3. All of them are maximal parts such that their sum is at most 6. So the answer is going to be 4. Is this one fine as well? Yes, I agree. This problem was very long. It wasn't very good. The statement was very long for a very easy problem. And that wasn't very good. You want me to write the code? Do all of you want me to write the code? Let me first sign in. If you want, maybe I can write the code for this one, because this is very simple and fast. If you want, I can do that. If the majority of you want that. But if you want me to move on to the next problem, I will move on to the next problem. Yes, it is very short. Maybe, yeah. So let's start implementing it in very fast way. So we can just do this in this problem. I think, let me see what was the value of n. N is at most 100 and k is also at most 100. So I define const int of n equal to 100 plus 5 int n, k, and a of n. So it's very easy. We just seen n, k for int I equal to 0, sin ai, and we have some value of sum equal to 0. Sum can be sum will be int as well, so we don't need to worry about that. So each time I just say this, and I say ans equal to initially I set ans equal to 1. So I say that if sum plus ai less than equal to k, sum plus equal to ai, else sum equal to ai, ans plus plus, and cout ans. I think this should work if I don't have any bug. So I do not compile it, I will not test it. I think I can just submit it and see what happens. I hope that everything goes well. If sum plus ai was less than or equal to k, I add this one to the first group, I mean to the group that I have already. Otherwise I start another group with this group alone. I will start another part with this group number I alone, and I will add one to ans. So let's see what happens. It's possible that we get compilation error, but let's see what happens. Yeah, it got accepted. So yeah, this is how, for example, we can do problem B. Is it okay? Shall we move on to the next problem, or yeah, because you wanted me to code it, I think it wasn't a bad idea, because the code was also very short and it took a little bit of time. So C was harder than usual. Let me see. Okay, let's move on to problem C, if there are no questions about problem B. A good statement, first of all. For positive integers x and y, define f of x and y as the remainder of x plus y divided by 10 to the 8th. Okay. Remainder of x plus y divided by 10 to the 8th. You are given a sequence of positive integers a1, a2 to an of length n. Find the value of the following expression. Okay, sum of f of ai and aj's. And all the values are at most 10 to the power of 8. I see. So f of x and y is just x plus y modulo 10 to the 8th, right? So the first thing that came to my mind was that first I will just calculate sigma of just ai plus aj's. I ignored that modulo part because each ai is less than 10 to the 8th. And then this is easy, right? Because each number, it would be equal to sum of ai's times n minus 1, because each value will be in a pair with n minus 1 other numbers. So I just first calculate the sum of each two pairs, the sum of the sums of each two pairs, and then I should subtract from them the number of pairs such that their sum is greater than or equal to 10 to the 8th. For example, if the number of these pairs is, for example, p, I should subtract from this value. I should subtract from this value p times 10 to the power of 8. Okay, because all the numbers are less than 10 to the power of 8, right? All the numbers are less than 10 to the power of 8. So it's just possible that f of x and y is equal to x and y only if x plus y f of x and y is equal to x plus y only if this number is greater than or equal to 10 to the power of 8. I should subtract 10 to the power of 8. Otherwise, I should do nothing. So if I just calculate that for how many pairs the sum is greater than or equal to 10 to the power of 8, I can just subtract all of them, and then here I just calculate this value, the sums. And this is not division, this is just, I mean, this is equal to this. Sorry for that. Okay. So that's all. I calculate n minus 1 times the sum of the numbers that I have. Then if for two numbers, the sum of them, for example, for these two numbers, maybe the sum of them is greater than 10 to the power of 8. Greater or equal to 10 to the power of 8. So I should subtract 10 to the power of 8. And how can I find that for how many pairs this is possible? I mean, for how many pairs the sum of them is greater than 10 to the power of 8. This is an easy upper bound, I think, an easy lower bound. I can just save all the values in a vector and I can just source them. And for each number x, using lower bound, I can find out how many numbers are greater than 10 to the power of 8 minus x. How many numbers, using a lower bound, I can find out how many numbers are greater than or equal to 10 to the power of 8 minus x. Right? And if x was in there, I mean x itself, x plus x itself was greater than or equal to 10 to the power of 8, I should subtract 1 from it, because one pair is x and x itself, which is not valid. So this way I can count the number of bad pairs and I can subtract them. AI plus AJ is less than or equal to 2 times m minus 1. Yeah, it is always like that, because AIs are less than m. All the AIs are less than m. So AI plus AJ is less than 2m, right? If I got the problem correctly. And yeah, order does not matter because you calculate each pair only once. Yeah, and I can have a vector and source the vector and just do lower bounds. Is it okay? Do you want me to implement this one as well, or it is okay? Yeah, order does not matter, because you just consider each pair once and it's just sum of x and y. F of x and y is equal to f of y and x. Okay. Show the code or implement it. I mean, show the codes of others. I'm okay with both. If I want to show someone's code, maybe we can C++, status accepted, search. Yeah, I can implement it as well if you want. Let me just implement it then. Well, we can just say that in here we need a long, or no, we do not need a long. Yeah, for the because for final answer we need long. I just make everything long. Okay, it's cd using name space cd. Because we're gonna need long, I just define int long here, so that I make sure that everything is long line. And then I have const int of n at most 3 e5 plus 20 int n a n. Now I seen n for int I equals 0. So I get the input, and I just need to have all of them in a vector. I say vec.pushback AI, and I will source my vector, vec.begin, vec.end. Initially my answer is gonna be this. Initially my answer is gonna be sum of all the AIs times n minus 1, because they can be in a pair with n minus 1 other elements, right? They will be calculated with n minus 1 other elements initially, if we just calculate the sum. Now I want to see that for how many pairs. Int of, I can say maybe bad pairs, for example. The pair that their sum is greater than or equal to 10 to the power of 8. So I will have for I from 0 I most n, I will have int of id equal to lower bound of vec.begin, vec.end, and a of I minus vec.begin. Sorry, not a of I, 10 to the 8th minus a of I. I define m as 10 to the 8th. This is 10 to the 8th. So m minus a of I, right? I should find the values greater than or equal to this. And the number of them is gonna be n minus id. Okay, because this is the first element greater than or equal to n minus ai. If I subtract n from it, it will be all the number of numbers greater than or equal to this. And if ai itself, if ai plus ai itself was greater than or equal to m, I should subtract 1 from num, because ai calculates itself as well, but it shouldn't calculate itself, because it wouldn't be paired with itself. Why ai is multiplied by n minus 1? Because I said that I want to calculate for each pair. First, I just want to calculate x plus y. So I'm saying that each number will be in exactly n minus 1 pairs. So each number will be counted n minus 1 times. So what I'm saying is that each number will be counted n minus 1 times. Therefore, I multiply each one of them by n minus 1. Yes, every AI appears in n minus 1 calls to f. Yeah, exactly. Also, yeah. So now we have id equal to lower bound of vec.begin, vec.end, m minus ai minus vec.begin num equal to n minus id. If ai plus ai itself was greater than or equal to m num minus minus, and I should subtract. I have to add to bad pairs num, and I should divide the number of bad pairs by 2, because pair of I and j will be counted twice, once I and j and once j and I. So I should divide them by 2, and then I should say that ans minus equal to bad pairs times m, and then I can see out ans. Yeah, there's a high probability that this time there can be an error in my code, but we can test it out. We can submit it and see what happens. Yeah. So we see in all the values, then we source the vector, then we say that ans is initially plus equal to ai times n minus 1. The number of bad pairs is initially 0, and each time for each ai, I just find the first element greater than or equal to m minus ai, and then I set num as n minus id. ai plus ai was greater than or equal to m num minus minus. Bad pairs plus equal to num. Bad pairs I divide bad pairs by 2, and then I say ans minus equal to bad pairs times m. Does this make sense? That's what I'm doing. You can submit it and see what happens. Where I submitted to A. Sorry. I had to submit it to C. But anyways, it has compiler. Oh, I made a bad mistake. Yeah, why bad pairs divided by 2? Because as I said, I calculate pair of I and j twice. Once I and j and once j and I. Once for I will find j, and once for j I will find I. So I should subtract them by 2. And what is m? M is 10 to the power of x. Yeah, it got accepted now. M is 10 to the power of 8. I define it as 10 to the power of 8. And in here I say that I will find all the numbers greater than or equal to m minus ai. For example, in the first example, we had, for example, 5. For example, we had this number and this number, right? The point is, when I count the number of bad pairs, once for this one I will find this one, and once for this one I find this one. So the number of bad pairs will be 2, but I should divide it by 2 so that it would be 1. Because this pair is counted twice. Once for this one is counted, and once for this one is counted. So, yeah. So, shall we move on to the next problem? Is everything clear with this one? If it is, we can move on to problem D. Okay. Problem D, another sigma problem. For positive integers x and y, define f of x and y as follows. Interpret the decimal representation of x and y as strings and concatenate them in this order to obtain a string z. Okay, the value of f of the value of f of x and y is the value of z when interpreted as a decimal integer. Okay, so we just concatenate these two numbers. For example, f of 3 and 14 is 314, f of 101 is 1001. You are given a sequence of positive integers of length n. Find the value of the following expression modulo this mod. Okay. Well, okay, I see. In this one, well, the point is f of x and y. What is f of x and y? F of x and y is x times, I write it like this, is equal to x times the number of digits in y. Let me write it like this. Digits, the number of digits of y. I mean 10 to the power of the number of digits by y. Digits of y. F of x and y is equal to x times 10 to the power of the number of digits of y plus y. Do you agree with this? For clarity, let me write digits here. So f of x and y, I argue that f of x and I is equal to x times 10 to the power of the number of digits of y plus y. right? I argue that this is the value of f of x and y. Do you agree with this? So if I do this, then the answer can be calculated easily, because I can just save the sum of, I can just traverse the array from the left as well, I think, because we can start from the left each time. When we get somewhere, we just save the sum of the values of x's. When we are at some element here, for example, this is our y, we know that there are I numbers before it, for example, and the sum of them is equal to sum. I think we should just add this value to us. We should add sum times 10 to the power of digits of y to the power of digits of y, I just show it with d of y in here, plus I times y. Each time I can add this to my answer, and this is gonna be, this way everything will be calculated easily. I think this that's all. This is gonna be my answer. Right? So I just have some f of x and y, and I will start from the left, and each time I can say that because I know that f of x and y is equal to this x times 10 to the power of the number of digits of y plus y. So I can just save the sum of the numbers in this prefix. And how many numbers do I have before this y? And I should add to my answer sum times 10 to the power of the number of digits of I plus I times y. Oh, I see that you can't see the bottom part of the screen, so I write here plus I times y. Does this make sense? Oh, now I see your questions. I'm not getting lower bound. Yeah, exactly what Jason has said. Lower bound was just in order to find the number of elements that can be added to my element such that their sum is greater than or equal to 10 to the 8th. It was just this. Okay, is problem D fine as well? Shall we move on to the next problem or not? Okay, awesome. Yeah. So problem E. For a string, yet another signal problem. For strings x and y, define f of x and y as follows. F of x and y is the length of the longest common prefix of x and y. You are given n strings s1, s2 to sn consisting of lowercase English letters. Find the value of the following expression. Sum of f of si and sj. So for each two of them, you want to find the length of the longest common prefix. I see. Well, for example, here the length of the common prefix of these two is 2, for these two is 1, for these two is 1, so it's 4. Okay, So, well, the first thing that I think about when I see this problem is DSU. How, you know, if if for each value of k, first let's sort all the strings in lexicographical order. Okay, let's sort all the strings in lexicographical order first, and that can be done easily. We can just have their indices and sort the indices based on their lexicographical order, and we can compare each two string very easily and sort them in the lexicographical order. I mean, if you are, for example, familiar with suffix array, you know that's how we can sort some strings in lexicographical order, right? So first sort them, and then I'm saying that now assume that they are sorted in lexicographical order. I'm saying that my answer is going to be equal to this. If for each value of L, I understand what is the number of pairs such that their first L elements are the same. For example, here there are two pairs that their first L elements are the same. If I just calculate that and sum this value up for each L, that is going to be my answer. So I'm saying that my answer is going to be sum of G of L for L equal to 1 to at most the maximum length that we can have, which is going to be at most 3 times 10 to the power of 5. So L is from 1 to maximum possible length. So I'm saying that my answer, this value, is equal to the sum of G of L. And what is G of L? G of L means the number of pairs such that their first L letters are exactly the same. Hi. Okay, so for each L, I need to find out that what is the number of pairs such that their first L elements are the same. Why? Because if the LCP, if the longest common prefix of two strings is, for example, 5, this pair will be counted exactly 5 times. For L equal to 1, for L equal to 2, for L equal to 3, for L equal to 4, and for L equal to 5. So if the LCP of two elements is 5, two strings is 5, they will be counted exactly 5 times this way. So do you agree that this is equal to the sum of these values of G of L? If you agree with that, put a plus, please. Otherwise, put a minus or ask me questions if you have any questions. So I think the first step to solve such problem is figuring out that the answer is going to be the sigma of G of L's. And G of L means that if we consider the prefixes of size L, how many pairs do we have that these prefixes are the same for them? Yes, no problem. G of L just means that how many pairs do we have? G of L means that how many pairs do we have such that their first L elements are the same, their first L letters are the same. For example, in this example, G of 2 means that for how many pairs their first two letters are the same. We know that the first two letters of the first string is AB, for the second string is AB, and for the third string is AR. So only the first and the second one have the same thing, have the same letters. So the prefix of length 2 is equal only for this pair. So G of 2 is 1. What about G of 3? Sorry, G of 1. What about G of 1? For G of 1, this is A, this is A, this is A. So the prefix of length 1 of all of them is A. This pair is equal, this pair is equal, and this pair is equal. All the pairs are equal. So G of 1 is going to be 3. And g of 3 and everything more than 3 is equal to 0. G of x for x greater than or equal to 3 is 0. Because for no two strings, their prefix of length 3 or more is the same. Okay. So in here, I'm arguing that the answer is going to be the sum of gi's. It is going to be 1 plus 3, which is 4. Why? Because for each pair, you can easily see that, for example, for this pair, AB and ABC, how many times this pair were counted? How many times this pair were counted? I mean, I say that once they were counted in G of 2, and once they were counted in G of 1, right? So they were counted twice, exactly. And the point is, if the LCP of two strings is, for example, L, they will be counted in G of 1, G of 2, G of 3, to G of L. So they will be counted exactly L times. So this pair really contributes 2 to my answer. And this pair really contributes 1 to my answer. And this pair contributes 1 to my answer. So if I see each pair and I see that how much they contribute to my final answer, I know that this value is going to be exactly equal to the LCP of them. So I'm really calculating the sum of the LCPs. Does this make sense? Yeah, I will tell you now that's how to calculate G of L. But for now, is it okay that the answer is going to be equal to G of L? Okay, awesome. Awesome. So now the question is that how can we calculate G of L for each L? Well, as I said, we can just try to run DSU, and when we have sorted all the strings in lexicographical order, we can just say this. For when we have them in lexicographical order, we know that for each L, all the groups that their first L elements are the same, their first L letters are the same, they are all consecutive. When I sort them lexicographically, all the groups that their first L elements are the same are gonna be consecutive. So I'm gonna have a partition such that each part consists of some consecutive strings, right? So for each L, when I cut the first L elements, and I only care about the first L elements, we're gonna have several groups, and each group consists of several consecutive elements, right? So now I just need to find out that how can I merge these components together. Yes, for each two consecutive string, I can find their LCP only for each two consecutive strings. For example, if LCP of them is 4, for example, when my L became 4, when my L came to 4, I start my L from the maximum value, and I know that my answer is 0 there. And I go from the maximum value of L to the least possible value of L. And whenever I reached 4, I just know that I should merge these two components. So for each two consecutive strings, if I know their LCP, I can just easily say that I will merge them whenever I got to their prefix of that length. And then that's going to be all. They can be merged, and whenever I merge two components, I can easily update the number of pairs. The number of pairs is going to be choosing 2 from the number of strings in that connected components, and so I can easily update it. if I just save that, how many elements each group has, each connected component has. It's going to be 2 from the number of them, for example, k. So I can just run a DSU. I start from the end, and whenever I got to a pair with LCP-L, whenever I got to L, I will merge these two components. Does this make sense? How to maintain the number of elements in each group. That is just DSU. Are you familiar with DSU? I think you need to be familiar with DSU in order to solve this problem, in order to get exit from this problem. If you're familiar with DSU, you can just save the size of each connected component. Yeah, okay, sure. I can just save that in the root of your, you have several connected components. In the root of each connected component of your DSU, you can just save its size. And whenever you merge two connected components, you can just say that whenever you wanted to merge, you can just say that, for example, if this one is going to be your new root, you can say that size of v plus equal to size of u. Okay, so you can save the size of the connected components in the root of your connected components. Okay, and let me check the codes of some people to make sure that they don't have any easier solution for this. So let's see how others implemented it. For example, this is one solution. If you understood what I was talking about, you can just start analyzing this solution. No, I do not iterate starting from the last string. I iterate from the maximum possible value for L. So I start from the largest L, for example, start with 3 times 10 to the 5th, and I subtract L each time. Okay, and whenever I subtract it, whenever L becomes lower, I should merge several connected components. The reason that I start from the largest value of L and I go leftwards is because this way I can just merge some pairs. Okay, if I just make L smaller, more pairs are going to be equal after each time, and I can merge several connected components because they become equal after this step. Yeah, and how to decide which ones to merge? We just, for each two consecutive pairs, for each two consecutive strings, we will just say that, for each two consecutive strings, I can just find out what is the LCP of these two strings. I can just find what is the LCP of these two strings. For example, consider that the LCP of these two strings is 7. Then I can save that whenever my L became 7, merge these two. So I pre-process it for each two consecutive strings. If there, for example, LCP is 7, I just memorize that whenever my L became 7, I need to merge these two, the connected components of these two elements. Does this make sense? So I save that when I should merge these elements. Yeah, first I sort all the strings lexicographically, then I have an iteration on all the consecutive strings, and I find the LCP of them. Yes, exactly. And I save them, for example, in a vector. I can just say that, for example, vector of 7, if this is index, for example, 11, and this is index 12, I say that vec of 11 dot pushback vec of 7 dot pushback 11. It means that when my L became 7, I should connect, I should merge the connected component of 11 and the next one. Exactly. And each time whenever my L becomes some value, I have a 4 on its vector, I have saved already that which pairs should be connected. And then I will merge them and I will find the answer this way. Does this make sense for everyone? If so, we can also check this code. This one seemed interesting, so maybe there are other ways for it as well. Let me see. This seems interesting. It gets SCR. It just sorts them. This is for sorting in lexicographical order. It just easily sorts them all. And then compare L, R, and 0. Okay. It seems like he has done divide and conquer, he or she. This seems interesting, really, but because it is a short code, but it's not very obvious that's what he's doing. Yeah, if you want, you can spend time trying to find what this code is doing, and if you want, we can move on to the next problem. Which one do you prefer? Do you prefer to understand what this code is doing or move on to problem F? Move on. Okay. So I will move on to the next problem then. Problem F. Oh, what a statement. Okay. Has anyone solved F in the contest? Was anyone be able to read it? No, I just wanted to know if someone has solved problem F as well. So let's read it. Tiles are laid out on a coordinate plane. There are two types of tiles, small tiles of size 1 by 1 and large tiles of size k by k. Right. G was easier than F. Two types of tiles, small tiles of size 1 by 1 and large tiles of size k by k, laid out according to the following rules. For each pair of I and j, the square xy is contained within either one small tile or one large tile. If I over k plus j over k is even, it is contained within a small tile, otherwise it is contained within a large tile. Okay. Tiles include their boundaries, and no two different tiles have a positive area of intersection. For example, when k is equal to 3, tiles are laid out as follows. Yeah. So alternatively, we have either large tiles or small tiles. Okay, so it's like a chess grid. Just instead of black and white, we have large tiles or several small tiles. Takashi starts at the point s of x plus 0.5 and s of y plus 0.5 on the coordinate plane. He can repeat the following movements any number of times. Choose a direction and a positive integer n, move n units in that direction. Each time he crosses from one tile to another, he must pay a toll of 1. Determine the minimum toll Takashi must pay to reach the points tx plus 0.5 and ty plus 0.5. Okay. So he's in the middle of one of the tiles and he wants to go to another tile. And he wants to pass over the minimum possible number of tiles. So it's the best for him if he passes over large tiles instead of small tiles. So you need to find the minimum value. But this doesn't seem like a very neat problem. But anyways, what is the value of L K? I mean, okay, K is given to, okay. Well, yeah, I'm not sure I have a neat way to solve this one, but yeah, I see this pattern. I think that, for example, if you have a point in, for example, here, we should just try to repeat this each time we go like this. Sorry. This way we only see one small tile in our path, and until we will be even either horizontally or vertically in the same line with our goal. So I think this is the way we should move on, but I'm not sure how to implement it in a neat way. That's why I prefer if we can see the codes of some people to understand how did they implement it. Okay. Okay, this is a very neat way to implement. Seems like it is a very neat way. We know that all the values are up to 10 to the power of 16 or 2 times 10 to the power of 16. Okay, let's try to find out what this code is doing. It gets all the inputs and m is equal to the distance of them initially. F means 4, yeah, it's defined to 4. 4p from 1 to 4, 4q from 1 to 4, m is equal to minimum of m, and code of sx syp, oh, code of tx ty q. Okay, I think that these fours of size 4, these fours of size 4 is in order to find out that in which direction they should start. I mean, what is the if they are in a small tile, there are 4 big tiles around them. To which one of them they will go? Okay, so it's like the direction of their first move. I mean, instead of thinking that we start from here and go from here, we can assume that both of them can come to each other. I mean, we can just consider, I don't know why my sound is low. I'm really not sure about it. I really need to I need to check that more than this. I think I need to test it again after this stream, because it is said many times that the voice of the microphone is low. it is fine. What do the rest of you think? Is it fine or is it low? Maybe now it's better when I'm closer to the microphone. The tags, I think the tags is mostly implementation for this. So I just think that it just checks to which large tile it will go, and then from there it will be easier to find out the answer, because we can do the exact same pattern that we saw. I think that's the main thing that we should do on this problem. Yeah. And as you see in here, it just checks if a modulo 2 was not equal to b modulo 2, then it means that itself is a large tile. Otherwise, it finds out the first large tile and it will move to that side. Right? So yeah, I think that's how it does work. DFS, no, he doesn't run DFS because the limits are up to 10 to the power of 16. So DFS would be so huge and it wouldn't be very efficient. But yeah, you can just, the main idea, the general idea is this. The general idea of this problem. That's what I got from the code. The general idea is that we will find out what is the first large tail that the destination can go to, and what is the first large tail that our source can go to. We move both of them there. And if they're already in a large tile, they will stay there. Right? And then from there, it will be easy to find out what is the minimum possible steps to get from, what is the minimum possible toll to get from this large tile to this large tile. Because we know that what is the pattern. Okay. So I think that is the general idea. I don't personally like this type of problems very much, but what I got from it is that we can do this. I think that is the most that I can think of about this one for now. Does this make sense? Is it understandable what we're trying to do? So I think that can be considered as a hint. If you want to get accept from this problem, you can look at it like this. You will try to find out the large tile, the first large tile that you can move your both points to, and then try to find the distances from there. Okay, shall we move on to the next problem? I'm sorry that I can't discuss this one in detail, but I hope this much that we discussed would be useful. Yeah, maybe it is, but in not a very good way, because I said that I personally don't like such problems. For example, this doesn't have some elaborate algorithmic thinking, or I don't know, a nice idea. I personally don't like such problems, to be honest. But yeah, even if it is hard, it is not hard in a good way. You know what I'm talking about. And I don't think you don't need any specific algorithm in order to solve this. It's just you need to consider different cases. You just need to find out a good way to implement it. And the best way was maybe these codes that you will just try to find out. You know, it's like a dilemma. You do not need to have any prior knowledge for this one. And there's no specific algorithm that you need to know for this problem. You just need to find out that's how you want to solve this problem in a neat way. And one way can be trying to find that how you can move these points to the closest large tile. So I think that would be it. And there's no algorithms necessarily to know for this problem. Yep. So let's see what we can say about problem G. Problem G, the kingdom of Atkoder has n towns 1, 2 to n. To move from town I to town J, you must pay a toll of C times I minus Jn. Takahashi, a merchant, is considering participating in 0 or more of M upcoming markets. The ith market is described by the pair of integers TI-PI, where the market is held in town TI, and he will earn PIN if he participates. Okay. M upcoming markets. The ith market is described by a pair of TI-PI, where the market is held is town I, and he will pay PIN if he participates. For all I from 1 to M, the ith market ends before the I plus 1th market begins. The time it takes for him to move is negligible. For all I from okay, he starts with 10 to the power of 10 to the power of 100 yen and initially in town 1. Determine the maximum profit he can make by optimally choosing which markets to participate in and how to move. Okay. So yeah, the problem is saying that he has infinite amounts of money, so we don't need to worry about that our money will run out, but we want to maximize our profits. Okay. So will you stream lead code too? Uh, I, we can add the lead code as well. Do you guys all participate in lead codes? Can you tell me if you participate in lead code contests? If a considerable proportion of you, if many of you participate in lead code contests and it is useful for you, definitely we'll also cover lead code. Yeah, we can do that. Do you guys participate in lead code? I see, Rajiv. What about the rest of you? Can you explain the following solution to which solution? What do you mean by the following solution? No, Harshif. Okay. What about the rest of you? Okay, if you guys are going to participate in lead code contests, then yes, definitely we will cover those contests as well. So let me see the submissions of people for this one as well, so that we do not spend more time on this one. Let me see that how people got it accepted. You know, in AdCoder you can source codes by their code size and just see the smallest code. Sometimes the smallest code is not very neat because it has many defines, etc. But in general, you can find shortest codes first. This one is not very good as well. Why all of them define some OP? Okay. all the codes seem very similar. I don't know why, if they used each other's code or what, but they seem like very similar, many of them. Right, I see. Because of the time difference. Yes, yeah. Guys, where are you from? Tell me a little bit about yourself now that we are here. Where are each one of you from? And how old are you? Also tell me how old are you? Let me know you a little bit more. Rajiv is from India. Great. Glad to have you here. 21 years. From Bangladesh. 26 in August. Great. Tunisia, 26. Awesome. Awesome. What about the rest of you? That is awesome. Yeah, I am also originally from Iran and I'm 24. So we are almost from the same age, all of us. We are almost from the same age. I think ICPC, for ICPC there is a limit that you can only participate in the first 5 years of your university. There was a exception this time because of the coronavirus, and but in general you can just participate in the first 5 years. So with high probability not. With 29 or 30 years old you cannot participate in Codeforces contests. Yeah, and in this problem, as you can see, there were many different ways. One of them seems like to be that convex Hall trick that you mentioned, and one of them seems like to be segment tree. So I think when they okay, it seems like there is some tutorials for some of them, some of the problems. Yeah, I for this one again I cannot go in details. I think I need more time. If I was participating in contest, maybe I could tell you the solution of this one, but just its tag seems like segment tree or canvas Hall trick. So I think maybe it can be beneficial to just add this, but yeah, we could only discuss the solutions of the first 5 problems, but for the last 2 problems, for this one it seems like the tag is convex Hall trick or segment tree. Seems like both of them give you solution, and for this one it's just implementation, and you need to find out the largest tile, the large tiles which are you can go to from your source and from your destination. So I think that can be it for now, and that can be it for what we're saying today. Do you have any more questions from it? The solution is very short, nearly 20 lines. For this, for which problem? For problem G or for problem E? Because before you talked about problem E. Okay, which solution? Maybe we can check that out. Which solution? Can you write its ID? Okay, Abdurrahman, thank you. Abdurrahman says that problem G can be solved by using DP optimized using segmentary. Great, awesome. Have you solved it in contest, Abdurrahman? That is great if you have solved it in contest. And guys, just let me tell you something. If you are interested, you can do a streaming on this channel as well. That is completely open. But there's just something that because we want many of the problems to be solved in these streams, we expect the streamers to be master or grandmaster or IGM or LGM. And if you are master plus, if you are a master or greater in Codeforces, and you are willing to stream on this channel, you are welcome. You're more than welcome. That is completely open. And if you are interested, you can just contact me in Discord or in Codeforces, anywhere, and tell me that you're interested in doing streams. And it is paid, obviously. I mean, for each stream that you will do, you will be paid because you are doing some work on this channel, and that is totally appreciated. Yeah, great. Great, Abdurrahman. Abdurrahman, yourself, even if you want, that is so good that you solved problem G. And if you want for the next time, you can also do stream if you are interested. And anyone else from you, Dimitri, Rajiv, anyone. I said that the only condition is that we need the streamers to be master plus, and that's just because we need many problems to be solved, and we don't know. I mean, that's the only way that we can check that out, and we have no other choice, unfortunately. So if you are interested, you can just message me and you can start the streaming. You can also do other contests. We want to start covering Code Chef as well, Lead Code as well, and I would really appreciate it because you're all nice guys, and I would really appreciate collaborating with you. So if you want, just message me, and you can also do streaming in here if you are interested. Okay, let's consider the submission. For problem E, oh, that seems very neat. What is it? Oh, okay. It uses hash. Okay, it uses hash. It is not a definite answer. I mean, hash can sometimes be wrong, but if you use your mode and your base properly, that's a low probability that it would be wrong. And in the worst case scenario, you can use double hash so that you can make sure that it's gonna be accepted. So this code uses hash function. It just starts from the beginning and just calculates the hash of the first elements. I mean, each time updates the hash. And for example, when it is at prefix number L, it just checks that how many other people had the exact same hash and add that value to ans. And again, if the LCP of two values is, for example, 10, this pair will be counted exactly 10 times, because after adding the first letter, they are the same. After adding the second letter, they are the same. After adding the third letter, they are the same, and so on. The purpose of map is to save that for any hash, how many of the strings had this hash for their first letters. So it is very rare that two strings are not the same, but their hash is the same. So if now you're considering a string of J letters and its hash is H, you can assume that the hash of the other hashes, which are the same, correspond to the exact same string. So they are the exact same string in other strings. Is it understandable? It is just using hash. Okay. So we are just using hash, and for it, that is a very good solution. And thank you very much for sending this submission ID. That was very neat solution and very easy solution, because the solution that we discussed was hard to implement, but this one is very easier to implement, and that's great. So you can just save the hash of each prefix, and then just by doing this, you can just move forward and just see that how many other strings had this exact same hash, and definitely they had the same prefix with this one, so you can add them. And this way, if the LCP of two strings is, for example, 7, this pair will be counted exactly 7 times. Okay. So awesome. Yeah, this was a neat solution. Do you have any other questions about it? I think I missed some questions. Let me just check everything again if I missed anything. Okay guys, if you asked any question and I missed it, you can ask it again, because there was some periods of times that I think I missed some messages. But if you have any question, you might ask it now. What is your advice for AdCoder to excel? Same strategy you talked about for CF? Yes. Because if you see, most of the time the people who excel in AdCoder are exact the same people who excel in Codeforces. So there are not much difference between these two. You don't see that someone is not good in Codeforces at all, but it is so great in AdCoder. No, maybe that it is a little bit different, but they are almost the same. I mean, the people, for example, if Tourist is great in Codeforces, is the greatest in Codeforces, then Tourist is also the greatest in AdCoder, and so on. If you have some level in Codeforces, you have almost the same level in AdCoder. So yeah, there's the same strategy. You should improve in competitive programming, and you can train. For example, in Codeforces, you can sort the problems and start solving them. Yes, there's the same strategy for both of them. So yeah, if you excel in Codeforces, you will excel in AdCoder as well. And you're gonna have the almost the same level in both of them. Does that answer your question? And does anyone else have any question? Okay, awesome. You're welcome. Thank you guys. Thank you all for joining. It was so great to talk with you again and have a stream with you. I hope that we can have more streams, more videos, etc., and we can talk more with each other and improve together. Okay, so see you on the next one. Tomorrow is another contest. I will try to stream it myself, but if I couldn't, I will ask others to ask them if they can stream it. But let's see. And if you want, again, I say that you are completely free. You can just tell me and get to know more about it. And if you want, you can also start streaming on this channel. This channel is not for me, just for me. It's channel for really for everyone who wants to help. And you're more than welcome to do anything you want on this channel. Thank you very much. It was nice to have you today. Goodbye.